Hi, this is Umut Kocasarı, and I am going to present StyleMC, multi-channel based fast text-guided image generation and manipulation. This is a joint work with Alara Dirik, Mert Tiftikçi, and Pınar Yanardağ from Boğaziçi University. Here is a teaser for our results. Our method is capable of performing complex text-driven manipulations on diverse datasets, such as beard on FFHQ and classic car on Elsun car. Unlike prior work, StyleMC requires only a few seconds of training per text prompt to find these stable directions. The text prompts are shown below the images. Our motivations are as follows. With our method, we enable fast text-guided image generation and manipulation with any pre-trained new StyleGAN2 model. Unlike previous methods, we find stable and global manipulation directions in a few seconds. Our purpose is to find multiple style channels that control the attributes specified in input text and use clip to guide the manipulation. We also employ several strategies to speed up the process, which we discuss next. Our framework is intuitive and efficient. Using a pre-trained StyleGAN2, our method takes a text prompt T, such as a face with mohawk hairstyle, as input and finds a manipulation direction delta S, such that G of S plus delta S generates a manipulated image in which the target attribute specified by T is present or enhanced, while other attributes remain mostly unaffected. We use a combination of a clip loss and an identity loss, taking advantage of the disentangled nature of the style space S. The clip-based loss minimizes the cosine distance between clip embeddings of the generated images and the text prompt T. Identity loss minimizes the distance between the input images and the generated images. We initialize delta S as a vector of zeros and minimize both of these losses. After training, the direction delta S can be applied either to randomly generated images from StyleGAN2 or to real images inverted by a StyleGAN2 encoder. We use 128 randomly generated images to identify the target style channels for manipulation. We find that using 128 images is sufficient to find stable and generalizable directions. The reason for this strategy is that the manipulation effect caused by the style channels remains consistent across all images. We use 256 resolution blocks to guide clip for speedup. We observed that using layers up to 256 to find the manipulation direction within the S space could give similar results to using layers up to 1024, but it is much faster. We also perform all operations in S space because S space is more disentangled compared to W or W+. Here, you see the manipulations of directions found by our method. We see that our method can perform complex edits ranging from stylistic edits such as curly hair or beard to emotional edits such as relieved or excited. In this figure, we see the results from different StyleGAN2 models. Our method is capable of handling a variety of simple and complex edits, as can be seen in this slide. When we compare our method with other text-guided methods, we see that our method can perform complex manipulations on par or better than TeddyGAN and StyleClip at a fraction of the time they require. You see examples of complex manipulations such as Trump, Mohawk, and Makeup. Our method takes significantly less time than TeddyGAN and StyleClip methods to find directions and perform the manipulations. It only takes 5 seconds to find a stable and global manipulation direction compared to hours of pre-processing or training time in other methods. In this figure, we see comparisons of our method with other unsupervised methods. As can be seen, all methods perform similarly and can manipulate the images in the desired direction. We will show some example videos. Here is the edit for classic car on Elsun dataset. The edit for smile on FFHQ. And curly hair. And finally, here is the edit for text prompt woman on Medfaces dataset. As a conclusion, we introduced a fast and efficient method for text-guided image generation and manipulation. Unlike previous work that requires hours of pre-processing or training, our method requires only a few seconds per text prompt to find the global manipulation direction and generates results that are on par with state-of-the-art models, such as StyleClip in terms of quality. We apply a variety of manipulations ranging from simple style changes, such as hair color, to complex changes such as gender, personal identity, species. You can find our implementation at GitHub. And thank you for listening.